Good morning, everyone. I'm Joni, and I hope you're safe and you're making the most out of your time during this community quarantine. So, for today, we'll be answering some problems taken from various chapters from the university physics. This time, we'll be answering 3 problems from chapter 26. Let's start with 26.12. In figure E26.11, the battery has EMF 35.0 volts and negligible internal resistance. R sub 1 is 5 ohms, the current through R sub 1 is 1.5 amperes, and the current through R sub 3 is 4.5 amperes. What are the resistances R sub 2 and R sub 3? So let's identify our given values. We have our EMF 35.0 volts, R sub 1, which is 5 ohms, I sub 1, 1.5 amperes, and I sub 3, which is 4.5 amperes. And also, for us to be familiar with the figure, here's our figure. So R1 is parallel to R2, and this combination is in series with R3. So for this problem, we are being asked for the resistances of R2 and R3. To get that, we first solve for V sub 1. So using Ohm's law, we have V sub 1 is equal to I sub 1 times R sub 1. And substituting the values, we have 1.5 amperes times 5 ohms. This gives us 7.5 voltage. 7.5 volts. Now, since R sub 1 and R sub 2 are connected in parallel, we can say that V sub 1 is equal to V sub 2 is also equal to the voltage in R12, or the combination of R1 and R2. Therefore, V sub 2 is also 7.5 volts. Now, let's redraw the circuit. So we will combine R sub 1 and R sub 2 to get R sub 1, 2. Since R sub 3 is connected to R sub 1, 2 in series, we can say that the total voltage in the entire circuit is equal to the sum of V sub 1, 2 and V sub 3. Now, manipulating the formula to get V sub 3, we have V sub 3 is equal to EMF minus V sub 1, 2, or 35 minus 7.5. So, V sub 3 is equal to 27.5 volts. Now, to solve for R3, using Ohm's law and manipulating the formula, we get R sub 3 is equal to V sub 3 divided by I sub 3, or 27.5 divided by 4.5 amperes. This gives us a resistance of 6.11 ohms. Now, redrawing the circuit again, since R sub 1, 2 and R sub 3 are connected in series, then we can say that I sub 1, 2 is equal to I sub 3. Therefore, I sub 1, 2 is equal to 4.5 amperes. Now, looking at our original illustration, since R sub 1 and R sub 2 are connected in parallel, we can deduce that I sub 1, 2 is equal to I sub 1 plus I sub 2. Or manipulating the formula to get I sub 2, we have I sub 1, 2 minus I sub 1. Substituting the values that we have, 4.5 amperes minus 1.5 amperes, this gives us a current of 3.0 amperes. Now, to solve for R2, using Ohm's law, R sub 2 is equal to V sub 2 divided by I sub 2, or 7.5 divided by 3.0 amperes. The resistance is 2.5 ohms. Next problem, we have 26.27. In the circuit shown in figure E26.27, find A, the current in the 3.0 ohm resistor, B, the unknown EMFs E sub 1 and E sub 2, and C, the resistance R. So this is our given illustration or figure with the flow of the currents being identified also. So for letter A, we are to find the current in the 3.0 ohm resistor. So this is the 3.0 ohm resistor, the one in the middle. So we apply junction rule to this point. So the summation of the current is equal to 0, or -3 minus 5 plus I is equal to 0. Transposing I to the other side, we get 3 plus 5, 8. So the current is 8 amperes. Letter B, find the unknown EMFs E sub 1 and E sub 2. So to do that, we apply loop rule to loop 1, which I have identified as this loop. So summation of voltage is equal to 0. So we have E sub 1 minus 4 ohms times 3 amperes minus 3 ohms times 8 amperes equals 0. Or E sub 1 minus 12 volts minus 24 volts equals 0. So we get E sub 1 as 36 volts. Now for E sub 2, hang on, we're having some technical difficulties. Alright, so we apply loop rule to loop 2, this loop. So summation of V is equal to 0. E sub 2 minus 6 ohms times 5 amperes minus 3 ohms times 8 amperes. E sub 2 minus 30 volts minus 24 volts equals 0, so that E sub 2 is equal to 54 volts. And finally, find the resistance R. So we apply loop rule to loop 3. So summation of V is equal to 0. E sub 2 minus R times 2 amperes minus E sub 1 equals 0. Now since we already know E sub 2 and E sub 1, we just substitute that. So we have 54 volts minus 2R minus 36 volts. Or 2R is equal to 54 volts minus 36 volts. Now we divide both sides by 2 so that R is equal to 9 ohms. And finally, we have 26.54. In figure P 26.54, the battery has negligible internal resistance and E is equal to 48.0 volts. R sub 1 is equal to R sub 2 is equal to 4 ohms and R sub 4 is equal to 3 ohms. What must be the resistance R sub 3? B, for the resistor network to dissipate electrical energy at a rate of 295 watts. So identifying our given values, we have EMF 48.0 volts, R sub 1 4 ohms, R sub 2 4 ohms, R sub 4 3 ohms, and P 295 watts. And here is our given figure. So R sub 1 is in series with R sub 2, and this combination is in parallel with R sub 3, and this entire combination is in series with R sub 4. So, what must be the resistance R sub 3? To solve for that, we use P is equal to V times I. So, from Ohm's law, we know that I is equal to V over R. Now, substituting our I to the equation for P, we can rewrite the equation for P as P equals V times V over R, or P is equal to V squared over R. Using this equation, we can manipulate the formula to solve for the equivalent resistance first. So we have V squared divided by P, or 48.0 volts squared divided by 295 watts. This gives us an equivalent resistance of 7.81 ohms. Now solving for R sub 1, 2, since they are in series, so we simply add R sub 1 and R sub 2. So 4 plus 4 gives us 8. Now to solve for R sub 1, 2, 3, we know that the total resistance is equal to R sub 1, 2, 3 plus R sub 4, because if we redraw the circuit, we can see that R sub 1, 2, 3 is in series with R sub 4. Okay, so R sub 1, 2, 3 is equal to the equivalent resistance minus R sub 4. So 7.81 minus 3. This gives us 4.81 ohms. Now, since R sub 1, 2 is connected to R sub 3 in parallel, we can solve for R sub 1, 2, 3 using the reciprocals of R sub 1, 2 and R sub 3. Now, manipulating this formula to get R sub 3, we have 1 over R sub 3 is equal to 1 over R sub 1, 2, 3 minus R sub 1, 2. Substituting our values, we have 1 divided by 4.81 minus 1 over 8. So this is 319 divided by 3,848. Now we get the reciprocal. So R sub 3 is equal to 12.07 ohms. That's it. Thank you for watching. I hope I was able to help you somehow.